And once again, welcome back to my YouTube channel. Let's continue with calculations from the graphs, okay? And these are the types of questions that you're going to see in your paper, okay? Where, like how in functions, we ask you sometimes to sketch a parabola, hyperbola, exponential, or else sometimes we give you the parabola, hyperbola, and exponential, and then we want you to solve for the actual values in the equation. It's similar to that, okay? Now with our cubic function, there isn't much to know in terms of what does the a value stand for and b value and c value, stuff like that, like how you would know the m value in y equals to mx plus c is our gradient. You don't have to know stuff like that. What you do need to know is how to find the stationary points, how to find the point of inflection, those kind of things, and use that to your advantage and work backwards from there. That's what we're going to be doing, okay? You should also just know that this value over here is basically our y-intercept. So it says, this is the question, the diagram below shows the graph of f of x equals negative x to the power of 3 plus ax squared plus bx plus c. Automatically from here, just looking at that negative, we know it's going to be decreasing, increasing, decreasing, which is exactly what we have over there, okay? It says with turning points at A, so there it is, and B, which is 6 and 0, okay, there it is. I'm going to fill that in, 6 and 0. Okay, and it also says that the graph also passes through the origin. So automatically we know that our x-intercept over here is going to be 0 and 0. There's two x-intercepts over here, 6 and 0, 6 and 0. And we also know that our y-intercept is 0 and 0, meaning that the c value over here is just going to be 0. The first question, again, then here's a sketch, and if you see in the sketch I have point D, which is 3. Please don't ever assume that a point, I know it looks like it might be the point of inflection, do not assume that it's the point of inflection unless we tell you this is the point of inflection, okay? And you'll see in this question it's actually not even the point of inflection, right? So please don't assume that. Okay, the first question says determine the values of A, B, and C, which is what we're going to do. Let's have some paper from here. Okay, determine the values of A, B, and C. So what I'm going to do over here is I already know that our C value is 0. So okay, then we know that our x-intercepts, I mentioned this, are at 0 and 0, 6 and 0, and 6 and 0. If I had this equation over here, it can be rewritten as basically, well, not this particular one, but any equation can be written as okay. That means we multiply in each of the x-intercepts. That's what's happening, okay? In this particular question over here, we know that our x-intercepts are at 0, 6 and 0, and 6 and 0, right? So that means it's going to be x times that's what we know, okay? And then we're going to, and we also know, sorry, I forgot to mention, or forgot to copy it down, that this value here was actually a negative, so please fill that in over there. Okay, right, I'm going to multiply this out, giving me and then I'm going to multiply that into there. And you would notice this is exactly what we got over there with our d value being, oh well, in this case it's called C, our C value being 0. Can you see there's nothing added to it? We figured out what our A value is. There it is, 12. We figured out what our B value is. There it is, 36, negative 36. C value is 0. Okay, I'm just going to mention that. Hence, there we go. Okay, next question says, determine the coordinates of A. We were told that at A, it's basically the turning point. If you watched my previous video, you know that a turning point is where the derivative is equal to 0. So, right, I'm going to take this equation over here, find the derivative and equate it to 0. Oh, dividing everything by negative 3, giving me and then I'm going to find factors. So x equals to 6 or x is equal to 2. If you would notice, this is actually the b coordinate, isn't it? There it is over there. So we're not concerned about that one. We're concerned with this one over here. My y value at this point, I'm going to take 2 and sub it back into the equation, not this equation over here. Negative 32. Please don't forget, whenever we ask you for a coordinate point, we want you to write it back into coordinate form. So 2 and negative 32. Okay. Next question. Determine the coordinates of the point of inflection. We know point of inflection is where the second derivative is equal to 0. Okay, so this was my first derivative. I'm going to derive it again to get my second derivative. To find the y value where x is equal to 4. I have the equation typed in, I'm just changing it to 4. Negative 16. What did our question say? It said determine the, where was it? Determine the coordinates of the point of inflection. So basically the point of inflection is at 4 and negative 16. We put it in coordinate form. Okay. Next question. It says E, determine the equation, D, determine the y coordinate of the point D if the x coordinate is 3. So there it is. We need to figure out what the y coordinate is. That one's quite simple. All you're doing is you're substituting that 3 into the equation. So we're going to say Okay, I'm going to just change this now to 3. Negative 27. I'm writing down the point. It's 3 and negative 27. That's point D. Next question. Determine the equation of the tangent to the curve at T. So T was 3 and negative 27, right? When we want to determine the equation of a tangent, we need a gradient and a point. My gradient is going to be where my first derivative sub in the point 3, isn't it? So my first derivative, where was it? Negative, this one over here, negative 3x squared plus 24x minus 36. I'm subbing in the point 3 because remember we want the gradient or the gradient at that specific point, right? This here gives me so my equation is y is equal to 9x plus c through point D, which is 3 and negative 27. That's the equation of this point over here, the equation of the tangent at the point T, which was 3 and negative 27. Okay, next question. Determine the coordinates of the point at which the tangent again cuts the curve. Okay, so that same tangent that we were given, right? We know that this tangent is drawn somewhere there, okay, and it's going to be touching, because we're extending it like this, it's going to touch the curve somewhere, okay, or cut the curve somewhere. So where it's going to cut the curve is basically where we're equating this one over here with the equation of the curve. So I'm going to say y equals, this was f, y equals 9x minus 54, this is equation 1, and y equals negative x to the power of 3, what was it, x to the power of 3 plus 12x squared minus 36, that was our equation, we're equating them. Okay, now we need to actually solve for this. So in order to solve for this, you're going to use table mode, and you're going to find one of the possible values, and then you're going to do synthetic division, and then you're going to find your actual values. So let's do that, and I'm going to show the people who have a silver calculator. I'm going to show you with mine in case you don't know how to find those values. So for the rest of us, table mode. I'm going to start at negative 5. You can start anywhere. End at 5. step 1. I'm looking this side here for a 0. There we go, we got a 0, and it's where x is equal to 3. So that's one of my possible factors. Okay. And I need to find the other one. How do I find the other one? I need to say at 3, bring down this value. This is going to give me negative 3. 12 minus 3 gives me 9. 9 times 3, 9, 18, 27. Okay, these are the coefficients of the quadratic part of it. So we got negative x squared okay, could have taken out that negative over there. That's what I'm going to do. And I'm going to factorize this. Okay. Right, then you can use the quadratic formula, or you can use your grade 9 factorization. Don't forget to take out that negative over there. So that means our possible values are x is equal to 3, or x is equal to 3, or x is equal to 6. Now if you go back to that point T, right, because that's one of the points where they're intersecting, it's at 3, right? So that means we're not concerned with this value over here. We're basically only concerned with this value of 6. And you're going to sub the 6 back to either one of these equations. So I'm going to go with that first one, 9 times 6 minus 54, leaving me with 0. So this here is at 0. So another coordinate point where this tangent and the curve are going to intersect is at 6 and 0. If we go back to our graph, it's basically at this point over here, it's going to cut again. Okay, that just happened to be coincidental in this case. It doesn't always work out like that. All right, those are the type of questions that you're going to get. I'm going to put onto the group for you guys some questions that you guys can try. Please practice them and then go through past paper questions as well and see how those questions are asked. Okay, I'm going to make a separate video for you guys on graph interpretation, the stuff over here, and questions like this. Please, for this question over here, my suggestion to you is that you actually take highlighters and walk through it. It makes it so much easier. I am going to scan all of this and put it on the group for you as well.